in the lab activities the two different types of bonds, both covalent and ionic. The ionic bonds, I'll remind you, I'm sure you already know, are the types of bonds that are formed from the transfer of electrons. If there's one word to describe ionic bonds, it's transfer. Electrons are transferred from one atom to the other. Ions are formed. You're going to have positive charges and negative charged ions. Opposites are attracted. Together they go. With our covalent compounds, we're sharing electrons, and we've done the Lewis dot structures to indicate what type of bonds, how many bonds, whether they're doubles, triples, etc. So here's what we want to be able to do today. Really, we got 4 learning targets there, but they're the same for each of the 2 types of compounds. So for our covalent molecules, we want to be able to name the compound from the formula, and we want to be able to write the formula from the name. Same with the ionic. If you've got the formula, we want to be able to state the name. If you have the name, we want to be able to write the formula. Easy peasy. Let's start with molecular compounds, or covalent. When you hear molecular compounds, or it means the same as covalent compounds. If you hear covalent compounds, we're talking about molecular compounds. So here's a couple of examples of pictures of molecules. Ozone, O3, CO2, carbon dioxide, methane, CH4, boron trichloride, BCl3. That stuff we've already done with our molecular geometry, but although we've given you the names and the formulas in some cases, we really haven't talked about what the process is for naming them or determining the formula from the name. That's the plan for today. All of our molecular compounds are going to be formed between nonmetals. Nonmetals. So I might write that at the top, on the back above your molecular nomenclature. Just write nonmetals, or nonmetal plus nonmetal, or covalent, or molecular. Look, everyone, stars. When you see stars, that means it's time to write in the box. So molecular nomenclature. This is our prefix system. We're going to use prefixes for this. Step 1. I know, sorry. You're fine. We're going to list the most metallic atom first, and we're always going to write the full name. On the periodic table, metals are on the left. We don't have metals in covalent compounds. So our nonmetals that are most metallic are going to be the left side of our nonmetal section of the periodic table. So silicon is going to be more metallic than phosphorus, which is more metallic than sulfur, which is more metallic than chlorine. Another way to look at it is not necessarily the more metallic, but the least electronegative. So our electronegativity decreases as we go down and to the left, or increases as we go up and to the right. So whichever one is more left or more down is going to be the element that we list first. Step 2, we're going to add prefixes. You're good. Yeah. You don't have to write it word for word. You're going to add prefixes before each atom. The one exception is that you do not write mono before the first atom. And we're going to go through a number of examples to illustrate both this, that we don't use mono on the first atom, and that we don't double up our vowels. And for those of you that write really fast, and you're ready for step 3, we don't have to worry about charges at all, which probably doesn't have a whole lot of context to you at this point, but when we get into ionic compounds, charges are a big deal. But here, with covalent, no charge, it's like a shopping spree. You don't have to worry about any charges. And then finally, step number 4, or as they would say in Greek, step tetra. That's too bad, sorry. We're going to change the ending of the last word to IDE. And you'll see on your cheat sheet on the front side of your note-taking sheet, there's a whole bunch of common roots that I've provided for you, that we've provided for you. Oxygen becomes oxide, fluorine becomes fluoride, chlorine becomes chloride. The covalent compounds, I think, are definitely the easier of the two types. Not that either one of them are really that difficult, but once we get a couple of examples with the covalent compounds, they're pretty much all the same, only different. The only thing that's going to change is the prefixes. So here's the prefixes. Those are also provided for you on the cheat sheet. Mono is 1, di is 2, tri is 3, tetra 4, etc., all the way down to deca for 10. You will need to know those. I don't anticipate that we'll be giving you Greek prefixes on tests or quizzes, but they're not all that overwhelming. Let's go through a couple of examples. You should have these on the right side of your note-taking sheet. CO and CO2. Using our rules for naming, we've got the first one listed. What element do we have here? Emily? Carbon. And how many of them? 1. What do we have here, Gabby?
Oxygen.
Oxygen. And how many?
1.
1. So we're going to name our first element, carbon, using the full name. There is only one of them, but we do not use the mono prefix for the first element. So we're not going to say monocarbon. It's just carbon. And we've got 1 oxygen, so our name becomes
Monoxide.
carbon monoxide. Giddy up. And how's that different than this one? Here we have 1 carbon and 2 oxygen. So instead of carbon monoxide, Brock, what are you going to have? Carbon dioxide. Here you can see that we have dropped that O in mono. I know it's still there, but we dropped it because we already have the O from oxygen. So it's not going to be monoxide or anything like that, it's just monoxide. Second one, N2O. Lauren, how many nitrogens?
2.
So what's our first term going to be? We're going to use a prefix for, dinitrogen. And we've got 1 oxygen, which we're going to drop the end of and end it in IDE. Use the prefix mono to indicate that there's only 1 of them. So we're going to have dinitrogen monoxide. Does anyone have any questions yet?
No. The whole thing. Just this one.
Yeah.
One more going this way. SF6. Mallory, what's S? Sulfur, yes. F6. Miss Kane? Fluorine, and there's 6 of them. So we're going to have sulfur hexafluoride. Again, any questions? Yes, dear.
How come, like, for the N2O, like, monoxide is, like, on the
We're,
is it because there's, like, monoxide?
I'm sorry?
Like, it's like the monoxide, like, is it because there's only like one oxygen?
Yep. We always are going to use a prefix for our second element, even if it is just one. So because there is only one oxygen, it's going to be monooxide, but we drop that O. The only time we don't use a prefix for the first element is if there is just one. So we don't write mono for the first element. But if there's 2, 3, 4, 5, 6, 7 of them, we're always going to use a prefix for the first element except for one. Is that good? Okay, let's go the other way. Arsenic trichloride. How many arsenics? 1. Uno. How many chlorines? Tricycle, 3-wheeled little bike. So we're going to have 1 arsenic, 3 chlorines, AsCl. How many Cl's? 3. So just like we don't write the prefix mono for the first one, we also don't write 1 as a subscript. If there is no subscript, the assumption is that there is one of them. So do this next one yourself. Dinitrogen pentoxide. You're fine. Brandon, what do you got? Dinitrogen pentoxide. N2O5, perfect. Tetraphosphorus decoxide. Logan, you got it? The last one, tetraphosphorus decoxide.
There's 3 phosphorus.
Because
4 phosphorus and 10 oxygen.
10 oxygen, good. That's all there is for those. I didn't give you any more examples because, as I said, they're all the same, only different. The only thing that's going to change is the subscripts to use or the prefix to use. But if you have the prefix, you can cross-reference with the subscripts. If you have the subscripts, that's going to tell you what to use for a prefix. So the only thing we have left for covalent stuff is a very funny comic. Oh, that's funny. Yep.
I'm gonna do that.
Carson's is
Okay. You get it?
Anybody I need to explain this to? It's funny. Okay. All right. The bigger chunk of this class is going to be talking about ionic compounds. And it doesn't have to be a lot bigger, as fast as you allow me to. But with our ionic compounds, initially we're just going to focus on binary compounds, which means there's only going to be 2 elements in our formulas. Later we'll move on to more complex compounds, but for right now, binary, we're going to have one positively charged ion, which we call a cation, and a negatively charged ion that are going to combine to form our compound. And the example that we've talked about a number of times already is, simple one is sodium and chlorine. Sodium, very likely to lose an electron because it's in that first family. It's got 1 electron to lose, so it becomes a positive 1 charge because it's deficient 1 electron. Chlorine, in family 17, has 7 valence electrons, very excited to pick up another electron, becoming negative 1 charge. We've got a positive charge and a negative charge. They balance out to form a neutral compound. It is important, paramount, we'll even say, that your compounds are neutrally charged. So, pretty much the whole focus of figuring out what these formulas are going to be is looking at the charges so that we can combine these ions in a way that they produce a neutral compound. This is going to go very quickly. You've got a periodic table on the other side of your cheat sheet. We've gone through this a number of times in several different units. The different ionic charges. So all those in family 1 are losers. They lose 1 electron to become positive 1 or 1 plus ions. Family 2, losers, 2 electrons. They become 2 plus charges. Family 3A or 13. Again, losers. They want to get down to 0 to become stable. So they lose 3 electrons to become 3 plus charges. 4A. They could go either way. Are they going to gain 4 electrons or are they going to lose 4 electrons? Most likely, neither. That's where carbon is, and we saw in the last unit that carbon is excellent at sharing, loves to share. 5A, closer to 8 than it is to 0, so they're going to gain 3 electrons, or have an excess of 3 electrons, hence the negative 3 charge. Nitride, phosphide, arsenide. Group 6A, the oxygen is going to be plus or minus 2 charge, and 7A minus 1 charge. Our noble gases, they're stable, they don't form ions. Oh, we got a lot of stuff here in the middle. Group B elements, or our transition metals. Well, these guys get a little dicey because they can form, some of them can form more than one type of an ion. So many of these transition elements have more than one possible oxidation state. When we talk about oxidation states, that's really just another term or another way of describing what the charge on an ion is going to be. One example is iron. It can become a +2 or a +3. Well, whether it's a +2 or a +3, we need to be able to communicate that or determine that from the formula. And so we use Roman numerals, and you'll see that in a couple of examples coming up. If it says iron 2, that means the charge is +2. If it's iron 3, the charge is +3. There's a couple, tin and lead in particular, that are not in the transition metals that also have multiple possibilities. Tin 2, tin 4. If you're not familiar with Roman numerals, I don't know if you are, but I'm guessing you probably know the first 5 Roman numerals. If you don't, I'm going to tell you what they are. 1 is 1, 2 is 2 ones, 3 is 3 ones, 5 is a V, and 4 is a 1 before the V. But you're going to see that again on another slide. Lead can also be +2 or +4. There are 3 transition metals that are always the same charge. You should know those 3. They are silver, zinc, and cadmium. And Mr. Gussie pointed out in the previous class a very simple way to remember what the charge is for each of those 3. If you look for silver here, whoop, there it is. It is in family 11. What's the last digit in 11? 1. What's the charge on silver? 1. Zinc, family 12. Last digit, 2. Charge, 2. So neat. Cadmium, there it is. Family 12. Last digit, 2. Charge on cadmium, 2. It's like giving you the answers. So make sure you know those 3. This just summarizes everything we just looked at. So you should know the charges for most of those main 7 families and those 3 extras. How am I going to remember the difference between a positive charge and a negative charge? Positive charges are called cations, aka pussycats. See? That's a pussycat.
Did you make that one up?
I didn't. I wish I had. Anions, well there's anion there. She's unhappy, so negative. Definitely all crabbers. All right, oh look everyone, stars.
Where? Don't write that first. Yeah, don't write that. That's not
Yeah. All right, so for ionic formulas, we're going to write the cation first. We will not show any charges in our formulas. We'll work with the charges to figure out what the formula is going to be. When you're writing the formula, you're going to write the symbol for the cation first. Oh, come on. That's all there is.
Wait, so is overall charge that 1.1? Wait, what? So it's 1?
The overall charge of your formula must be equal to 0. And we illustrated that when we talked about sodium and chlorine. Sodium has a +1 charge, chlorine has a -1 charge. +1 and -1 adds up to 0. You're done. So if the charges cancel or are equal, all you have to do is write down the 2 symbols. NaCl. If the charges are not the same, you're going to write subscripts to indicate how many of each atom you need so that the charges do balance. And we're going to go through plenty of examples with you. A simple method for doing that is the crisscross method. And then finally, after we've crisscrossed, if we can simplify our subscripts, if for example we have x2, y4, we're going to simplify that down to 1 and 2. Or if it's 2 and 2, it becomes 1 and 1. Okay.
Not to be confused with their other hits, Warm It Up, Chris, and their less popular I Miss the Bus, which was the actual school bus to take it to school.
Let's listen.
Look it up.
Yeah, let's go.
It's like 33 million views.
On a sadder note, did one of them die?
One of them died about 2 years ago, yes. He lived a very fast life, jumping.
All right, so here's the first example of how we're going to work with our subscripts, so our charge is to find subscripts. We got magnesium, has a +2 charge. Chlorine, -1 charge. That means we're going to need 2 of those -1 charges to balance with our 1 +2 charge. So what does our formula become? MgCl2. Write the cation first. No charges in the formula. Charges don't balance, so we use the subscripts to balance the charges. Let's show you again with crisscross. We got magnesium, 2+, chlorine, 1-. We go, boom. Our superscript, or our charge, becomes the subscript on the other atom. And the 1 from our chlorine would come down here. We don't write that as a subscript when it's a 1, so we end up with 1 magnesium and 2 chlorine. That's not so bad. Let's do something. Oh wait, let's remind you about the Roman numerals. Lead 2 chloride, the 2 in the parentheses. Roman numeral 2 tells you the charge. So that tells you your lead is going to be a +2. From that, you can figure out what your formula is going to be, because you know that chlorine always has a -1 charge. So we're going to need 2 of those chlorines to balance with 1 lead. Carson, if this was lead 4 chloride, what would be different? What would that 2 be?
4?
Yeah. What would that 2 be?
A 4?
A 4. See how easy that is?
No.
Yeah. Those are your Roman numerals 1 through 5. 1, 2, 3, 5 - 1, and 5. You'll need to know those. Okay, here's your first example. Barium nitride. First thing we're going to do, write down the formula for the cation and the anion, including the charges. So you're going to write down barium, find it, it's in family 2. So when we did the predicting ionic charges, we know that it's going to have a 2+ charge, bless you. What's going to be the charge on the nitrogen ion? Where is it? There it is. What do you got, Laura? 3.
Why is it
Oh.
one side of the minus?
That's because, it's fine, it's normally written as 3 minus, but Mr. Blackford just did a little typo error in his efforts to hurry and have this be a wonderful little presentation for you. You're going to check to see if the charges are balanced. They are not. 2 and negative 3 do not cancel each other out. So we're going to make them. Our 2 is going to go down to the nitrogen. Our 3 is going to come across. Our 3 is going to come across to the barium. And we're going to have 3 bariums, 2 nitrogens, Ba3N2.
Are these the steps that go on like the naming ionic compounds?
Oh, yeah.
Oh no, there'll be stars for that.
So all, when the subscripts will always be positive, they like always just
Are you asking if subscripts will ever be negative? Yeah, they won't. Question was, will your subscripts ever be negative? No. Subscripts are negative, never negative. Your charges will tell you how many of the other atom you need, or the other ion you need, but this just tells you there's going to be 2 nitrogens. You can't have negative 2 nitrogens. Lithium oxide. Charge on lithium.
one plus
There he is, +1. Oxygen, -2. Nice. See how I got the number in front of the charge that time?
Oh, yeah.
Nice job, Steve-O. Check to see if the charges are balanced. No, they're not. Crisscross. 2 goes to the lithium.
Got it right.
Whoops, so fast. 2 goes to the lithium, 1 goes to the oxygen, Li2O.
Oh my goodness.
Oh my goodness. I think I have more examples of these than what we need, so I'm going to skip through the last couple. You still have 2 more on your sheet though, right? Iron 3 chloride. What's the charge on iron? Somebody hook me up. Charge on iron. Ben? 3 plus, you bet. Charge on chlorine? -1. Very nice, Maddie. Balanced? No. How can they be? Well, we're going to need 3 chlorines to balance with that 1 iron. Boom. Too fast?
So you just, it doesn't even,
What? Talk to me. The 3 from the iron goes down to the chlorine, the 1 from the chlorine comes down to the iron, but when it's a 1, we don't write 1. This is the last example I'm going to do with you, or the last one on your sheet for name to formula.
okay.
Aluminum, 3 plus. Sulfur, 2 minus. Do they balance? No. 3 is going to go down to the sulfur, 2 is going to come down to the aluminum. That's going to give us -6 from our sulfur, because we're going to have 3 of them at a -2 each. And +6 from our aluminum, because we're going to have 2 of them at 3 each. And giddy up. How's that work? Like $1,000,000. Do we need any more examples of those? I got like 3 or 4 more, and I don't want to go through them if we don't need them.
No.
Magnesium selenide, both +2 or both 2, +2 and -2, they cancel out. Please do not write, don't do crisscross when they're already balanced. Don't write Mg2, Se2. That would be one that needs to be reduced. If there's 2 of each, then we want 1 of each.
Yes.
Zinc iodide, so fast, +2, -1. We need 2 iodide to balance with 1 zinc. Aluminum arsenide, they're both plus, they're 3 and -3, so they're balanced 1 to 1, done. Okay, last thing. Ionic nomenclature. Next slide's gonna have stars.
Okay.
Okay, so we're gonna write the cation first, then the anion. Look, everyone, stars. Write your cation first, then the anion. With the cation, we're going to write the full name. Guess what step 3 is? How to write the anion. Root plus IDE. So calcium and chlorine, CaCl2 becomes calcium chloride. We don't have to use any prefixes because the charges on the calcium and chlorine imply how many of each we have. Oh, so fast, sorry. Oops. I'm going the wrong way. That's where you wanted me to be. Sorry. Now can I go?
Yeah.
How about now? Now? What now?
Why is it just chloride?
Because the charge on the chlorine versus the calcium tells us calcium's always going to be +2 because it's in family 2. Chlorine's always going to be -1. So the only way that those two are going to combine is going to be 2 to 1. If we have a metal that can form more than one ion, then we have to indicate what the charge is through Roman numerals. So the only time we indicate the charges with our ionic compounds is with the Roman numerals. That's going to tell you of a specific charge. And the only time we need to specify is when we're dealing with these transition metals or tin or lead that have more than one possibility. And so we tell you what that which charge it is with the Roman numeral. Now you've got 2 examples to go through. What are the 2 examples on the bottom of your sheet? Last 2.
So they were like in it. Calcium chloride 2.
Oh, calcium chloride 2 we just did. And this lead chloride we're doing. Mr. Gus is passing out a worksheet. And you're going to look at it and you're going to say, holy buckets, there's so much. And then he's going to tell you there's really not that much.
We're going to do a bunch right now, too.
Okay, here's a flow chart. You have that same flow chart on your cheat sheet.
Yes. Oh, is he right here?
If there's no metal present,
I am so sick of you. Good.
sure. Yep.
All right, guys, let's take a look at these. So we're going to be doing this exclusively tomorrow in class. So this should help a lot. I know it looks like a lot. Believe me, some of these take like a second or two. Some take a little longer. So we'll see. So let's look at this. Number 2. Stay with me here, please. First off, on that title, this is the key. Are you doing prefixes or are you doing charges? So above on the title, what I would do to the right of molecular covalent compounds, I'd actually write prefixes. This whole page is about prefixes, just so you know. So number 2, both sides. Its full name, as Mr. Blackford said, and then the second one, you drop the ending at IDE. Just how do you apply the specific parts of either a prefix or a charge. So number 2, SiO2. Si is what? Silicone. So you just write silicone. SiLicon. Put a space. Then we're doing prefixes. There was only one of those, but if there's only one for the first one, you don't say anything. So the second one, you have 2 oxygens. So the prefix for 2 is di, and then you put oxygen, you drop the ending at IDE, so it's dioxide. So you got silicone dioxide for number 2. Number 10, N2O. If you have more than one in the beginning, got to put a prefix. First one's still full name, so that's just simply nitrogen. So it's dinitrogen. And then what did Mr. Blackford say? The second one always has to have a prefix. So carbon monoxide, it's not carbon oxide. So it's mono, don't have 2 vowels in a row with the prefix to the element. So it's monoxide. You'll get really comfortable. There's only so many elements that we're ending with. It's not like the entire periodic table. You're going to start noticing there's a lot of trends in what we have. Let's jump down. 22. I love these. You could finish 22 through 36 like that. What element is that first one? Just the element. Phosphorus. Phosphorus. So I write a P. How many are there? 4. Boom. What's the other letter? S. 3. Notice, I did not crisscross. You crisscross charges. You do not crisscross prefixes. And some of you will start to do that. If you keep that straight, man, that's easy. Boom. You just bring them straight down. Bring them straight down. So that's 22 through 36. Flip the page. Again, I know it looks like a lot. We're doing great on time. We have more time than last hour. We're going to get more done. This, just analyze this for a second. On the left is all atoms. So if you see an element or an ion on the right, it's the element without a charge on the left. Okay? So, for example, I got a couple here. So this says zinc, or ZnCl, then there's a double line, and then it says this, and then that's it. So, what we need to do is figure out the ion for chlorine. Well, where does that come from? It comes from the periodic table. Just remember, -1, -2, -3. So that is a -1. So I write my chlorine as Cl-. Like you're writing in this, I'll underline what you're writing in. And then what do I have to do? Put it together. What do we do with charges? We crisscross. So it becomes ZnCl2. Do not write the 1s. We don't write a 1. Jump down. 57. Check this out. Immediately, the atoms, you just write them in. That's Pb and Cl. Those are just atoms. Just no charges. Everything on the left columns are just atoms. Then, I do need to put these in here, but I need charges. So, believe it or not, Cl is always -1. So it's -1. But, I don't know the Pb. Shoot. It's one of those that I don't know. It's a transition metal or an outlier right here. So, there's a thing called a reverse cross. What charge would Pb have?
4.
And would it be a positive or a negative? Positive because it was the first one. The first one's always positive. The second one's always negative. There's a lot of trends. I mean, this, you can fly through that. Flip the page. I want to do a little bit of everything so you get a feel. Okay, tomorrow in class, we are not writing any new examples. We are using these. Lithium bromide. Okay, suggestion. I'm going to write it down once. One of the most important things Mr. Blackford pointed out was that these charges are there and we're crisscrossing everything else, but when you're all said and done, you can't have charges in your problems. So I would suggest on the left, you do a little work. Just a little, it doesn't have to be really pretty. I got to figure out the charges. You can't have your final answer have charges. So, lithium, you had that one in an example earlier. That is +1. We can just put a plus. And what's bromine?
-1.
Just -1? Okay, great. Oh, those are going to even out, right? And if you need to visually see that, that's great. But my final answer needs to be written without charges. Now, if you can do it in your head, great. And some of you, as we go, will start doing it like, you know what, I'm going to write them next to each other and just visualize the two charges. Great. But just to let you know, you cannot write them with charges. And finally, FeO. Naming, I believe, is harder in Ionic. No, wait, sorry, the other way around, because you got to come up with charges. Now I'm getting confused. But there is one part of this that's hard. First, what's not difficult? Every single time, full name. Second one, drop the ending at IDE, right? So just do this with me, write iron, leave a space. And then I'm going to end it as oxide, right? Oh, why not a prefix? These are charges. If you want to write charges by your title, you can. Charges are different than prefixes. Here's the only question you have to ask. Every time you write this down, you have to ask yourself, do I need a Roman numeral? And all you got to do is say, if it's located in here, or tin or lead, and I always say, like, if it sounds like a metal that I knew before I ever came into chemistry, like calcium I didn't know was a metal before I came into chemistry. If it sounds like it's a metal, it's going to need a Roman numeral. What's the Roman numeral? It's the charge. Well, there's no charge. Right, so this one is equal to that. What is that?
1. Or -2.
That's -2, so if that's 2, this one had to have been a 2. That's the only way you can figure it out. It's not memorizing Roman numerals. It's whatever this is, and we can compare. If, just last thing, and we're going to be good. If you have that, you can actually literally do a reverse cross, and if there's a number, and that tells you that's iron 3. So I like it when there's numbers. You can just bring it back up. Start working at it. We are going to be doing that in class tomorrow. Good work today.
So if I'm not going to be here for class tomorrow, should I just do this?
Yeah, that's what we're going to be doing.